Intercept there is a 5 meters. 5 meters.
5 meter the distance.
5 meters.
So the thing is like just to give you a context, right? Like you have used any iPhones with chargers, like wireless charging circuits or whatever. The distance between the transmitter and receiver, right? Like it's inversely exponential. Like when you move a couple of inches, right? The coupling completely gets destroyed. Like there is no magnetic coupling between these two. If you want to transmit from the ground level to the vehicles, probably like the ground clearance level, right? Like probably it will be, I would say, 20 centimeters or something like that. I have done a calculation on what is the size of coils that are required to couple. The more the distance, the size of the coil will be huge, right? Because when you want to magnetically couple two things, right? Like from the primary to secondary, when you have a 20 centimeter gap, so that is going to increase the size, the weight of the vehicle itself. Have you done some calculations on that?
Specification. So my question is related to the artificial intelligence. So what are you trying to do employing AI? So I just saw that you were trying to predict how much power that you will be needing, what kind of parameters that you think.
AI வந்து நார்மலாக யூஸ்
Maybe a little bit closer, right?
ஏஐ வந்து நாங்கள் நார்மலாக யூஸ் பண்ணுறோம். எப்படின்னா ஒரு 10 கார் ட்ராவல் ஆகுதுன்னா ஒரு ரோட்டில் இந்த 10 காருக்குமே சார்ஜ் வந்து தேவைப்படுது. ஸோ ஏதாவது 2 காருக்கு மட்டும் தான் சார்ஜ் பண்ணிட்டுருக்கோம்னா நாங்கள் அந்த 2 காருக்கு மட்டும்தான் பவராக இருக்கும். ஒரு ஐபிஎஸ் வச்சுருக்கோம் ட்ரான்ஸ்மிட்டர். ஸோ அந்த ஐபிஎஸ் அதை ட்ராக் பண்ணி அந்த ரிசீவர் மட்டும் ஆன் ஆகும். பவர் லோ ஆயிடுச்சுன்னா பவர் பேட்டரி சென்சார் வந்து லிமிட் பண்ணுவோம் ரிசீவருக்கு. ஸோ அந்த ரிசீவர் மட்டும் ஆன் ஆகும். ரிசீவர் ஆன் ஆன பிறகு ட்ரான்ஸ்மிட்டர் வந்து அந்த ஐபிஎஸ்ஸை ட்ராக் பண்ணி ரிசீவர் வந்து ரிசீவ் பண்ணுற மாதிரி இருக்கும். அந்த கார் வந்து ரிசீவ் பண்ணுற மாதிரி இருக்கும். பேட்டரி லெவல் இறங்காத கார் இந்த நாட் நீடர் காரில் வந்து ரிசீவர் ஆஃப் பண்ணும்.
Okay, so basically you are using GPS. My question is very specific to how do you predict how much power is needed? Yeah. So you said that you use AI to see how much power is needed for the battery according to distance and you will charge it, right? Have you explored about the models that could potentially use or the kind of parameters you can work with?
நார்மலாக ப்ராஜெக்ட் ஒரு 220 வாட் பிளாட்ஃபார்ம். ஸோ அதை ஸ்டெப் டவுன் பண்ணி கொடுக்குறோம். ஸோ நாங்கள் அதுக்கப்புறம் ரிசீவர் சைடு ஸ்டெப் டவுன் ஸ்டெப் அப் பிளாட்ஃபார்ம். ஸோ எவ்வளோ பவர் வந்தாலும் அதை ஈக்குவல் பண்ணலாம். பேட்டரி சார்ஜ் ஆகும்.
Another basic question. Do we know what is the power needed to move the electric vehicle? And how much energy is needed to charge them to wireless? Any rough idea if you have it? Let's say the Tata Nexon EV or whatever the vehicle. How much energy is needed? What is the battery capacity? And how much energy is needed to make this wireless charging? Batteries. I think this is one information. With 30 volt you can't move the vehicle. Normally the vehicle which with the 12 volt battery or whatever it is, you can just operate those electronic component in it. If you want to have electrical vehicle itself to move, you have really a high energy, around some 440 volt and so on. So almost 150 kilowatt power is what you normally need. Beyond it, it depends on the load of the vehicle and there are multiple parameters in it. So I think one point which we should appreciate in India is, I think it's good to have such a thoughts and then the innovative ways to think. I think it's a good thought process where we should do always, and it's a good thought process. And where people also need to focus is the feasibility of it. Yeah? Good presentation. Thank you.
Thirdly, we would like to call the team Clova Engineer to preside over.
A wonderful morning to one and all present here. Before getting into the presentation, let me tell a quick story how was this idea begin. As every story has a problem, this story is not different. One fine day, a boy was helping his father for piling the cotton into the gunny bags, which was harvested from their land. While doing the work, the boy thought that this work it's like a never-ending process. When this is going to end? So at that night, he thought somehow we have to find a solution for that. So the next day, he called his friends and discussed with them, and he came out with a solution. As all you guessed, the boy is me, Rajashnu from mechanical second year, and these are my friends, Ragavan from second year mechanical and captain of our team, Clova Engineer, and Paras Neeraj Kumar from second year mechanical, and that's how our idea came into the picture, the cotton packing machine. Now I quoted that it's a never-ending process, so let me explain that. In rural areas, packing of cotton into the gunny bags after harvesting for the purpose of transporting it to industries or government society is a huge process. As you can see in the picture, this cotton was compressed directly into the gunny bag with bare hands. Every time I have to jump into the gunny bag and I have to rush to tightly pack it. So this is how I have been sitting out there after completing this. The concept is we give more effort but only less amount of work, and it takes a huge time. So this is a hectic process. So now Paras will explain how we are going to tackle this problem. So over to Paras.
Okay, so the solution to our problem is the cotton packing machine. No, it's not as complex as it seems. It's just a simple piston and cylinder mechanism. Basically, we are going to use a piston to compress the cotton inside the gunny bag. So here comes the heart and soul of our idea. Basically, we are going to use electric motor as a source of rotational motion, and we are going to use crank and connecting rod system to convert the rotational motion into translational motion and provide it to the piston. The piston will be continuously compressing the cotton inside the gunny bag. And then basically how a user is going to use is that gunny bag will be clamped inside the drum, and then piston will turn on the machine and piston will compress the cotton. There will be an inlet through which cotton will be continuously poured in, and as and when the cotton fills, the drum will be lowered down by using a rail mechanism manually by the user. So here is a simulation of how. So here is a simulation of how we are going to use it, and here we have tried and simulated different parts of our cotton packing machine using ANSYS. Over to Raghav.
The simulation.
So I'll be explaining about the potential use case of this unit. This machine will be increasing the packing rate of cotton and reduce manpower and time consumption. So our ideology will attain its maximum potential use in rural areas. So coming to tech stack, we choose induction motor with the specifications of 2 HP and 500 rotation per minute, and next overload indicator. So it will be added on to our machine, so the operator can lower down the cylinder when it's needed. And we used ANSYS and SolidWorks to create and develop our product. So here comes the budget estimation. Induction motor, crank, connecting rod, piston and cylinder. These are we used general materials which are available in market, and their estimation are given here. And finally the attachment and others. This includes nuts, bolts, rail mechanism and etc. So we allotted 3,000 rupees for that. Finally the manufacturing. making this material, raw material into these parts, we allotted 5,000 rupees. So totally it will be around 21,000 to 25,000 for this one unit. And from here, Paras will continue.
So basically for our marketing strategy, first we are going to target the local market in Tamil Nadu. In Tamil Nadu, in an year, approximately 0.6 million bales of cotton is produced. One bale is 170 kilograms of cotton. So if a person has 1 acre of land, then approximately 1,100 to 1,500 kilograms of cotton is produced. And to pack all that cotton inside gunny bags, it takes around 30 hours. So basically here what we are going to do is reduce this time nearly 4 times and reduce it to 8 hours. How are we telling is that to pack one gunny bag, it takes around 1 hour, but using our machine, it will take only 15 minutes. So here are the gist of how wherever cotton is produced in different districts. So basically we can see Virudhunagar, Salem, Tirvarur and Perambalur is our major cotton producing industries. And basically we are planning to set up our industry in Salem, because in Salem there are a lot of steel plants from where we can import our raw materials. And then in the second stage we are planning to target the whole India. India is third largest producer of cotton, and 4% of GDP comes from our cotton. So due to this, I think that this project will surely succeed. Over to Rajesh.
So some of you would have think the budget of this project is so high, but let me give a justification for that. In India, approximately an acre can cultivate, can yield an income of around 1,67,000, and averagely profit will be around 80 to 1 lakh. So investing 21,000 is like a single time investment for a long term purpose. Though some of the small cultivators can't use it, let me give an example. The tractor, in villages not everyone own a tractor. Only a couple of members will have tractor and others will take it for rent and start farming. So same formula apply for this machine too. So it will be surely a successful project. Thank you. Actually, simulation video is not playing there. Let me show.
Can you play?
If possible, can you have a pen drive? No, I'm having laptop. Yeah, sure. We can.
So no sir, just clamping the gunny bag into the is done manually, and then after filing it completely, it will be removed from the bottom load. The bottom load is here. So you have to put the cotton into the drum or something. How do you press it? For example, first of all, it is being placed on the floor, right? So no sir, it will be placed on a rail mechanism like it will be above from the ground level. Initially it will be here. So the piston will move off the way. After compressing it off, it starts regularly and the current will get overloaded. So with the help of the overload indicator, it will be indicated to the worker. So if you use the lower down the piston can move. So what is the weight of the
So the weight, actually the bottle we are packing the total weight
floors, and the cylinder costs around 10 to 15 kg.
totally it will be like 100 kilos or
Mobile equipment, right? The heavy you have to take into consideration the design part of it. Where like the machine is very heavy, right? Otherwise you cannot transport it.
cement
Construction cement
Like really impressive. I like the top process. You have seen into the ground and I think you understand. And I could close it right now. My father is not in the cotton. And I know how hard it is to dump it into the countries. My idea also great social maybe become something like how you are handling the cotton. Speaker is Think of that aspect of external dependencies.
What they do is they collect it from the field, right? They store it think about what you want to do. From end to end, there are a way to space because already can have put something extra like that will not be able to market.
Fourthly, we would like to call the team Curious Minds to take over the stage.
Hello. So, good morning everyone. We are Team Curious Minds. I am Sri Kamesh Guru R, the team lead, and my team members are the countries with heavy population. The road expansion or the road growth is basically the 1/3 of the vehicular growth. So we can ultimately say that the emergency vehicles that would that takes the patients to the hospitals would suffer time delays in reaching the hospitals. So we have come up with a project idea for the Grand Tech First Skynet 1.0 organized by the IEEE student chapter of GCT. Our problem statement is automated traffic light control system using global positioning system and computer vision. So the overall objective of our project idea is to develop a traffic signal controller which can be sensitive to the changing traffic management policy, and like we can minimize the vehicle delays and stops in the traffic signals. So this can be achieved by the global positioning system and computer vision, and will be monitoring the emergency vehicle crossing the signals. So I'll hand over the session to my teammate Rahul.
Yeah, good morning, another person here. I will explain about the flowchart that I have here. Consider the ambulance is coming in the range 500 meters before backward to the traffic signals. There will be a GPS transmitter system to be fixed in our ambulance that will be transmitting the some range of GPS to the microcontroller chip. That will be received by the GPS receiver. And that receiver will be embedded to our microcontroller. That will microcontroller allow it to go to interface with the traffic light to change the signal. Okay, whether the ambulance is coming this way, okay, we give the green signal, pass it away, like it. In addition to that, we will use the computer vision for that, whether the received signal is for ambulance or not. We want to confirm it. Okay, for that we will image processing the ambulance. Okay, whether it is ambulance. To the we main using the OR operator here. Once the GPS is received and the computer vision is also received, okay, when the two ranges are accurately correct, our microcontroller is going to process the OR operator and passes the signal to this traffic signal. Okay, the ambulance is coming. The GPS is received for an ambulance such as a range. After that, our microcontroller is processing and passes the signal to our traffic signal. Okay, there will be emergency by ambulance is coming there. Kindly pass the signal to the green light and pass it away quickly like this. Okay, we can move into the tech stuff part. What are here? Okay, our microcontroller is a basic Arduino Uno is used here for that controlling the part here. Next for GPS module, I am using the Neo 6 GPS module for to interface with an Arduino module to receive the transmitter that is from the ambulance, transmit the GPS through this GPS module. And second to that, there will be a GSM to something transmitter that will be fixed in this ambulance. For the high-end ambulance, is default inbuilt it's fixed. For in case it is not available, we have to fix this in ambulance. That's camera module at last. It is used for the image processing for the computer vision in addition to the here. When the image is processed, all these parts are send the electric signal to our Arduino microcontroller. That microcontroller will process and give us an output to the traffic signal to for the electric signal like a light to green, yellow or red like that. I hand over the session to our teammate Aishwarya to further market strategy and budget.
Good morning all. So what happens when an emergency vehicle like ambulance or a fire service engine is detected? So the signal, okay, if it is red, it turns to green. If it is already green, the time gets extended by 30 seconds or 40 seconds according to the algorithm used. And next is estimation. We have used a basic controller Arduino Uno, which is cost effective and which is sensitive to the camera used here. It is sensitive and can detect the vehicles in range of 500 meter radius. And marketing strategy. So as already said by my teammate, it is used where the population like India, Thailand, where there is no possibility of road expansion or separate lane for emergency vehicles. So this project will be suitable for that. And further, so the targeted audience for this project is the government, the Ministry of Transport Department. So we'll be creating awareness by demonstration campaigns and advertising, social media advertising and digital marketing and the further extension, okay, this not only for detecting the emergency vehicles, this project can also be extended to detect the stolen vehicles and rules violation and helmet detection, which will be using different algorithms and different components, and these are the references. Thank you for
So like for the confirmation of the emergency vehicle. So with the GPS, we can like in the first stage would be getting the signal from the ambulance. So for the confirmation, the next stage confirmation, we are using computer vision. So in which lane, if it's a 4-lane road and we are having a traffic signal, so on which lane the ambulance is coming. So you can use the computer vision to detect in which lane we are getting an ambulance.
So the potential problem I could sense is that you cannot modify the traffic signals just like that. You cannot hold too much vehicles. The road itself has some capacity. And have you tried of any kind of simulation, or do you have any data that you could justify that this could work?
So still we haven't tried the prototype. So we waiting for
Probably like you have seen this scenario before, right? See, when you are in a vehicle, you will hear an ambulance, but you will not even be able to see the ambulance. That is one of the biggest trouble, right? Even see, we don't know whether it is coming in the opposite direction or it is behind you. So this is called the optical occlusion, right? One large vehicle hiding the entire scene. So try to find out. See, okay, optical is good because you want to put it in the camera at a place where it can see it, but better you can have a audio processing also.
For the further development, we include that sound sensor. It sends the which lane the ambulance is coming. where it is, like that. If the sound sensor gives us data to us, okay, this way the ambulance is coming. After that, the image processing will occurs and process the ambulance. It will go to the instant.
So one more thing is like you'll be able to hear an ambulance long before you can see the ambulance. You can do a lot of planning. There is a time gap. And you want to just run an algorithm to see what is the optimal flow and things like that. Just try to just suggestion like it's a good idea.
Thank you, sir.
Fifthly, we would like to call the team Electra.
Maybe do not go go beyond thing. Just give the gist, give the problem that you're trying to solve. Just explain the steps, because I think we have also limited time. We are sorry for that. And you would like to hear the gist and then your solution approach. Then you will feasibility of the solution.